Next up, we are going to talk about function notation. This is not a relation thing. This is strictly a function thing. So function notation, we generally have f of x in place of y. Why did we do this? Because we're mathematicians and we like confusing people. No, it's actually easier to keep track of what your independent variable is and what your dependent variable is when you use f of x. So you know that your f is going to be the name of your function. It's not always going to be f. Sometimes it's g of x. Sometimes it's h of x. Sometimes it's, a of x, s of x. It can be any letter, just like a variable can be any letter. But the letter that's on the outside of the parentheses is the name of the function. X is your domain value, and f of x is the entirety of f of x is your range. So we had talked earlier about how x is independent because we can pick what we want to put in there as long as it's part of the domain. Y or f of x is the dependent variable because we don't get to choose what that is. That's given to us based on what we chose for x. So let's take a look at finding the value of a function. So instead of writing out, this is our function, y equals 2x squared plus 3x minus 1, plug in 3 for x, we can simply say f of 3. So that's one of the reasons that we have this notation. F of 3 just means we're plugging 3 in for x. So let's go ahead and do that. So f of 3 equals 2. Oh goodness, my computer's gone crazy again. Sorry guys, making you dizzy. Okay, 2 times 3 squared plus 3 times 3 minus 1. Do our order of operations. Our exponent comes first, so we have 2 times 9. Plus 3 times 3 is 6, minus 1. 2 times 9 is 18, plus 6, minus 1. 18 plus 6 is 24, minus 1 is 23. Plug in negative 2 in for x. F of negative 2 is 2 times negative 2 squared. Now that negative is being squared, so make sure it's inside the parentheses. Plus 3 times negative 2 minus 1. Do our exponents first. 2 times 4. 3 times negative 2 is negative 6 minus 1. 2 times 4 is 8 minus 6 minus 1. And that is going to give us 1. So just to be clear, f of 3 equals 23. F of negative 2 equals 1. F of a. What? That's not a number. We can't evaluate that. This is actually kind of a nice one. All you have to do, change all your x's into a's. That's it. So instead of f of x, it's now f of a. So now it's 2a squared plus 3 times a minus 1. And we're done. That's it. That's f of a. We're good. All right, now we have a different name for our function. Now it's g of x. We still treat it exactly the same. Now we have g of h squared. Well, we're going to do the exact same thing we did with a, except now every time we see an x, it's going to be h squared instead. So g of h squared is 3. Now, instead of x, it's going to be h squared minus 5. That's as simplified as it gets. We are done. G of x plus 2. But wait, we already have an x. That's okay. Anytime you see x, now we're just going to put x plus 2 instead. So we have 3 times, make sure you use parentheses because it's 3 times x plus 2. because x is being multiplied by 3, so now x plus 2, the entire thing has to also be multiplied by 3. Minus 5. We'll distribute because we want to simplify this as much as possible. 3x plus 6 minus 5. And we get 3x plus 1. So, just to be clear, g of x plus 2 in our simplest version is 3x plus 1. Now we have g of x plus g of 2. Wait, which one do we plug into here? We have x, do we plug in 2? Do we plug in x plus 2? Actually, what it's telling us to do is plug in x for 1 and then add it to whatever g of 2 is. So we have to evaluate what g of x is, and we have to evaluate what g of 2 is, and then add them together. Well, g of x is already given to us, so that's nice. And now we have to figure out what g of 2 is. So we're going to plug 2 in for x. So we have 3x minus 5. 3 times 2 is 6. Negative 5 is negative 10. Plus 6 is negative 4. So g of x plus g of 2 is 3x minus 4, and that's our final answer. So there is problem 22 for you to work on. There are a lot of them, so just make sure you are going through and looking at them appropriately. So go ahead and pause the video, work on problem 22, and meet you back here in a few minutes. We'll talk about some word problems. All right, let's look at problem 23. You can see that many everyday situations can be modeled using functions. We're going to talk more about this type of function in our next section too. All right, let's look. The number of unread emails in Sylvia's account is 75. This number grows by 10 unread emails a day. The function n of t, and they just chose n at random, maybe for the word number, equals 75 plus 10t, represents a relation between the number of emails, n, and the time, t, measured in days. So what is the independent variable and what is the dependent variable? So we had talked about before that we got to choose what the dependent variable is. Can we choose numbers of days? I mean, we could plug in numbers of days and see what we get. So essentially, when we see the function notation, that's giving us a hint as to what the dependent variable is. What's inside here is independent. So what's inside here is time. So t, or time, is independent. N, the number of emails, n of t, is dependent. Find n of 5. Explain what this result means. All right, n of 5. This is exactly what we just did. We're just plugging in 5 for t. 75 plus 10 times 5 equals 75 plus 50 equals 125 emails. Oh my gosh. So what is this 125? Well, she already has 75 unread emails in her account. Sylvia, get to work. What are you doing with 75 unread emails? Anywho, it grows by 10 unread emails each day she doesn't look at it. Seriously, woman, look at your emails. So if she continues to procrastinate reading her emails for 5 more days, she's going to get 50 more emails, and she's going to have 125 unread emails in her box. So that's what this means. If she waits, I'm going to type this because, my handwriting is horrendous. If Sylvia waits 5 days without reading emails, she will have 125 unread emails in her mailbox. So we have a problem 24 for you to work on, and that is the last problem in this section. Good luck to you, and I look forward to working with you some more soon.